The structure of montmorillonite is a stratified structure, or a sheet structure. The crystal structure of this sheet structure has a thickness of 1 nanometer. It is several hundred nanometers in the lateral direction. The crystal structure is set up like this. The characteristics of montmorillonite are that the crystal layers hold a charge, and that it holds exchangeable cations in order to compensate for this electric charge. The amount of charge held by the crystal is called the crystal exchange capacity. The properties of montmorillonite change drastically depending on differences with the exchangeable cations. For example, if a monovalent cation, lithium or sodium, exists between the layers, water will hydrate around the cations and cause dramatic swelling. In contrast, if divalent cations, calcium or magnesium, exist between the layers, it will demonstrate limited swelling or a small amount of swelling. The swell volume appears smaller in comparison to cations that are monovalent. Montmorillonite swells upon contact with water. In a dehydrated powder state, it is approximately 4 milliliters or 2 grams as shown on the right. However, upon contact with water, it is apparent that the volume grows at or above 10 times as shown on the left. This swelled montmorillonite can be dispersed by shearing, such as by agitation. These scattered particles generate viscosity in the suspension. Furthermore, as the dispersed particles have a negative charge on the surface and a positive charge on the end face, when shearing is stopped, it forms an association structure called a card house structure. Thixotropy is generated in this manner. To illustrate, it becomes watery when shaken and jelly-like when left untouched. Summarizing the characteristics of montmorillonite, its size is 1 nanometer thick plate crystals and are around the same size as carbon nanotubes. The surface area of the plate crystals is around 800 square meters, which is around the same surface area as 3 tennis courts per 1 gram, or 1 teaspoon. Its greatest characteristics are that it demonstrates self-swelling and expresses a reversible viscosity. Furthermore, there are characteristics such as that it has ion exchangeability, has high heat resistance due to being an inorganic mineral, has a high level of safety such that it can be used as a food additive, and has little degradation over time. There are some differences depending on the product. However, the general characteristics of montmorillonite are shown in the following table.